air hydraulic intensifier, one of the coolest piece of device in pneumatic hydraulic system. It has ton of application. You can Google the application of this device. Will demonstrate, will show a calculation example, which is also very simple. So the design of this device is simple, the manufacturing is simple, and the calculation is also simple. One of the coolest thing about this is it can be run using as simple as a residential compressor. So let me show you how to perform the calculation. Now, before that, quickly, I want to demonstrate how this thing actually works. Simply, this air piston moves up and down depending on how the compressor is sending the flow. So there is a directional valve after the compressor. It can either send the flow in this blanket side of the cylinder or the rod end side of the cylinder, depending on what it is doing at this particular instance. So simply this piston moves up and down, and then that's how this load cylinder here, assume that it is handling 20,000 pounds just for the sake of this calculation example. So there is a resistance coming from this 20,000 pound resistance, which is pretty high actually, a empty semi-truck weight. So it's coming this way, and that will pressurize this oil. And according to Pascal law, it will have the same pressure everywhere. So this device is just compact one piece, so there is no elevation changes, so ignore about that. So simply pressure developed by this 20,000 pound would be this divided by the area of the load cylinder, which is pi by 4 2 inches square. So I calculated the pressure 6366 psi gauge pressure. Everything is gauge if it doesn't say anything, so I will not write gauge anymore. I'll simply write gauge pressure. So that will be, that pressure will distribute it right here. It's going to pressurize the air piston, which is this guy. And it'll provide a force here. So we can calculate that force simply by pressure times area. So pressure is 6366 times the area of the oil piston, which is pi by 4, 1 inch square. Oil piston is 1 inch square. So I calculated that force is 5,000 pounds. So this air piston is facing 5,000 pounds. And that 5,000 pounds is going to pressurize this air. So you can calculate that pressure, simply 5,000 pounds divided by the area of this air piston, which is pi by 4d squared. 10 inches square is given, is the diameter. So that will be the pressure, which is only 64 psi gauge. Now, any residential compressor is actually rated is about 150 psi gauge. Like I said before, that a residential compressor actually can easily run this 20,000 pounds. It can actually run almost twice more, almost 40,000 pounds, because this is only 64 psi gauge needed for these 20,000 pounds. So now the next calculation is the interest is not just the pressure, also the flow rate of the compressor, because that will determine how fast this 20,000 pound actually can be moved. So the compressor is not just the PSI rated, it also has some kind of flow rate rating. So standard cubic feet per minute. At a standard air condition, air temperature condition, how much flow a compressor can develop. So let's calculate that piece. So we calculated the amount of air. The pressure we need here is 64 psi gauge pressure. Now next thing we need to calculate the volume of air right here. So let's say this is our P1, and then we need to calculate the V1, the volume of air at that 64 psi inside the air piston. So simply the volume, let's say V1, 1 is our condition in the air piston, simply the area of the air piston times the stroke. so pi by 4, 10 inches square. That's the area of the air times the movement. So every second is moving 1 inch stroke. So it goes up and down. It's moved this way 1 inch. So divide by second. So I calculate this 79 inch cube per second at that condition at 64 psi gas pressure. So what you need to do is basically the outside condition, let's say that is 2, condition 2. So you can write P1 V1 is equal to P2 V2. So 1 is inside the air piston, which has a 64 psi gas pressure. You need to convert that to absolute pressure because everything in the ideal gas law must be in absolute value. And then the area at that temp pressure is 79 inch cube per second. Then the outside, the standard condition is atmospheric condition. Let's say that atmospheric pressure is 14.7 psi at the sea level. If it's nothing given, you can assume it's 14.7 psi at the sea level. Then you calculate the volume of air. So the volume of air I calculated was 419 inch cube per second. You do have to convert that to in foot cube per second. So 12 inch is 1 foot whole square. Sorry, that's cube times 60 second is 1 minute. I found this V2 is 15 standard cubic feet per minute. So this is how simple is the calculation is. So just simply operate this intensifier. You need a compressor that is as big as it can produce about 64 psi gas pressure, and it can provide a flow rate of 15 SCFM.